All right, let's do some graphing here. Today we're going to graph log functions. So I know we just started with logs yesterday. We have the kind of just the basic idea of them. But I think this is a good time to start graphing and get a little more clarity as to what's going on with logs. So I got 3 different functions to graph, some pretty good variety, and let's get to it. So I started out with one that doesn't have too much crazy stuff going on. All we have is just f of x equals, and then just there's not going to be any plus 5s at the end or a number in front over here or anything like that quite yet. So just pretty much the most simple type that you could have. Now here's the key. Here's the number one key to this whole thing, is what we're going to do is we're going to convert these to exponentials. We're going to get rid of the logs before we even start to graph. Instead of trying to plug numbers in here, which we could do, but you have to be pretty clever when you do that. Instead of doing that, we're going to convert this. So step one, just think of this as y equals log base 3 of x. And then let's use the only thing we know right now about logs is this. We know that the base of the log to this power is supposed to equal this thing over here. That's really the only thing we learned in our first lesson about logs, is that the base to the power over here equals this. This could have been over here equals y over here, and then it would have been 3 to that equals this. It's that little circle we were talking about yesterday. So the base to this power has to equal this. So what am I saying? I'm saying that we know that 3 to the y equals x. Which brings me to the next point, which is that logs are really just the inverses of exponentials. That's why we're talking about logs in this unit, is because they are the inverses or opposites of a regular exponential function. An exponential function is where the variable is the power. And in this case, that's exactly what we have. We have the variable being the power, but it's the y variable instead of the x. These have been kind of swapped around, and that's what an inverse is. So these being swapped is equal to an original function of a log function. Now, how do we want to graph this? Just like we graphed the exponentials before the break, we're going to just make a table. I'm just going to make a little table here. But I want to put y values into the table, because then I can just do this math right here and it'll spit out the x values. So I'm going to do something like this. Pretty rare that we do that. We usually are always picking x values to go here. But in this case, because log, when you convert it to exponential, it's the inverse, the y value seems more of what the thing you'd want to plug the numbers into. So that's why you see these numbers over here. Now I'll remind you again, I can't spend a ton of time on this because you guys need to be able to do this, but I'll remind you again that when you plug a -2 into an exponent like we're going to do right here, it does not create -9. It creates 1/9. This is going to be 1/9 because it's going to be 3 to the -2, which is 1 over 3 to the +2, which is 1/9. Once again, if you need to stop and pause that and think about that, go back to doing some arithmetic, you can, but I can't, it's not going to be fun to watch me keep doing this work all over this paper, all over the screen here, when it's actually pretty much just mental math. For example, the next one, if I put a -1 in there, this is 1/3. It's going to be 3 to the -1, which is 1/3. Anything to the power of 0 is 1. 3 to the first power is 3, and 3 squared is 9. Here comes the graph. All I'm going to do now is I'm going to plot these points right here. I'm kind of done with all this. I don't need to look at it anymore. I've got my values. This should be enough to see what this graph looks like. So 1/9 negative 2 is going to be like right in here. Kind of tricky for me to graph, but there it is. 1/3 negative 1 is going to be right about here. And 1, 0, that's a little easier to graph. And then 3, 1. And then 9, 2. 5, 6, 7, 8, 9, 2. And that's it. The graph's going to look like this. You're going to have an asymptote now. Your asymptote is going to be the y-axis here. This thing's coming closer and closer to here, but it never can cross over that spot down there. Let's do it again. A little messier. All right, step 1. Write y equals. Y equals 1/3 log base 6 of x minus 1. All right, next step is what we basically need to do is isolate this log part. We want to get this part to be by itself right here. So we're going to get rid of this negative 1, and then we're going to get rid of this 1/3. So we're going to add 1. So if we add 1, we will have y plus 1 equals 1/3 log base 6 of x. Then we're going to multiply both sides by 3 to kill this. We're going to get rid of this. So I'm going to put it's going to be a 3 over here, and with the parenthesis times y plus 1. So it's going to be 3 y plus 1 equals log base 6 of x. And now it's time to explain why I wanted to isolate that. The reason I only want this here and all this other junk over here is now I can do the rule that this, the base of the log, to the power of this mess has to equal this over here. So I'm going to write it that way. What that does is it gets rid of the log, so I can just do basic math. So it's going to be 6 to the power of 3y plus 1 equals x. And yeah, it's a little messy, but we can still handle this. We're going to just make another chart. And once again, I just want to pick some y values this time that I can plug in here. And at first you might not know what the good ones are, so you can still start. Let's see if this works again. Just start with kind of our basic, a couple of negatives, a couple of positives, and 0, and see where that takes us. Why would we know any different right now? So this number here, so if I put a negative 2 in right here, I get negative 2 plus 1, which is negative 1. And negative 1 times 3 is negative 3. And we can kind of see that I do want to show you some work here, and I'm going to have some trouble finding the space for that. So maybe I'll end up graphing it on a different piece of paper, different fake piece of paper screen. Okay. So maybe I'll just do some work here. So this is going to be 6 to the 3 times negative 2 plus 1, which is 6 to the negative 3, which equals 1 over 6 to the 3rd. And at that point, even if you don't know what that number is, what you do know is it's going to be a really small number because it's 1 over a big number. Okay, so this is, we can write it here if we want. It's going to be 1 over 216. Which is just, when we start graphing it, it's just showing that it's getting really close to 0. The next one should be a lot better though. So the next one we have 6 to the 3 times negative 1 plus 1. And that kind of changes everything because now it's 6. You get, basically you have 0 right here. And then 0 times 3 is still 0. So this is 6 to the 0, which is 1. So 1. Next one, if I put a 0 in here, you can see if I put a 0 right here, 0 plus 1 is 1. 3 times 1 is 3. So this is 6 to the third. When I put a 0 in right here, it's really just 6 to the third power, which is 216. Which all of a sudden is just way too big, right? And then from there, it just gets worse. And these, if you put a 1 in here, you now get 2. 2 times 3 is 6. 6 to the 6th power, huge. I'm just going to write huge and huge. Okay. The next question is, do we have enough, even though we really just have these, really, we know this is really small, we know this is really big, we know this is kind of a normal point, is that going to be enough to get a decent graph? So I went ahead and made it on a separate graph here just so we have some room. And so if you go, so this one, I mean, now we're talking like way, just right in here. This is, it's 1 over 216, negative 2. Well, 1 over 216 is barely over to the right and then straight down negative 2. And then we have 1, negative 1, which is right here. And then we get 216, 0, which I really can't graph. It's going to be, way over here, farther than this, way farther. Okay? But we can kind of imagine it, and so we end up with something pretty flat. It would kind of look like that. Now this is not an asymptote here, because like I said, I know that eventually this is going to hit, it's going to go up here and hit 0. It's just going to take until it gets to 216 to do it. So is that a decent enough graph? Probably, for what we're just getting started, trying to get you an idea of how this all works. Here's a third graph. Same idea. Step 1, y equals like that. And then same thing. I want to be able to go, I want to say this, the base of the log to the power of y equals this. But right now there's a 4 sitting in here. Well, I mean, I can't just ignore that 4. So this one can get a little bit tricky. So step 1 is, let's kill the 4. So we have to divide by 4. So we end up with y over 4 equals log base 4 of x minus 6. Now we can do our converting to exponential. So we have 4 to the power of y over 4 equals x minus 6. Let me explain that one more time. The base of the log to the power of the stuff on the other side of the equation always will equal this part right here. And then if I'm going to use my same methods, then I'm going to add 6. I'm going to take this 6 and put it on the other side, so I just have x equals. So it's going to be 4 to the y over 4 plus 6 equals x. And we're going to make our table. And once again, we're going to pick, I'm going to be a little smarter this time. I'm going to pick values for y to put in over here then I'm going to plug them in here, do the math, and it'll give me the x values to go with it. So I want to pick numbers. I don't want to be all messed up with this fraction here, so I want to pick numbers like, how about -4? I think that'll be an easy one. Certainly 0 and 4. I can think of some other ones that would work too, but let's see if that's enough to get us an idea what's happening. So if I put a -4 in here, that's -1. And 4 to the -1 is 1 over 4. So it's 1/4 plus 6. That's 6 and 1/4. I'm even going to just write it like that. Next one's a little easier. If I put a 0 in here, I get 0 here. 0 over 4 is 0. 4 to the 0 is 1, because anything to the power of 0 is 1. Plus 6 is 7. And then this one here, if I put a 4 in here, 4 over 4 is 1. 4 to the 1 is 4. 4 plus 6, 10. Six and 1/4 -4. So 1, 2, 3, 4, 5, 6, 7. -4. So this would look something like this. And you get 7, 0, which is easy. And then 8, 9, 10. 1, 2, 3, 4. Uh-oh. Now I'm off in this area. But we kind of have our idea here. We know that it's going to go something like this. And then, I mean, so we could stop there. I mean, we have the basic idea of the graph between basic, plotting points. You have a calculator. I'll show you how to do some of that stuff on there. We're in pretty good shape here. You're not going to have to do a ton of them. It's not like you got to do 100 of these or anything. So it's really just kind of take your time, think about, plotting points, how that works. But I wouldn't want to end this without explaining a little bit of connections here. Notice that here there's an x minus 6. And also notice that this graph is going to come down here and get closer and closer to 6. Remember, when this is minus 6, it's actually like going to the right 6 for the shift of the graph. And so there's an asymptote in there, right here. Right in there, there's a dotted line that's showing that this graph is going to get closer and closer to 6. These other numbers, here and here, if you want to see how those are related, really both of those numbers are just increasing, or in other words, changing how fast or slow the graph is going to go up. This could have been, if the numbers were different, it might have went like this or like this. So it's not quite as precise of a movement of the graph. But when you focus on this shifting stuff, the pluses and the minuses, they will just move the graph around. In this case, to the right 6. If this was a plus, it would have been, the graph would have been over here, etc. I think that's enough for the video. I will definitely take some time in class. We can talk about it live as well. But that should get you a decent idea of what graphing logs are about. It's all about, when you have a log function, your goal really is just to turn it into an exponential function. But by doing that, the y value is going to feel like the x value, because you're going to want to plug the numbers into the y. So it's for the first time this year we're taking we're picking y values as our beginning numbers that we're going to put into the function. And we're going to spit out the x values. All right. Work hard, be nice, see you soon.